In this video 6.1, we are going to be solving systems by graphing. By the end of the video and work time in class, you should be able to say, I can solve systems by graphing. A system of linear equations is when you have two or more linear equations. The solution of a system of linear equations is any ordered pair that makes all of the equations in a system true. What is the solution of the system? Y equals 2x minus 1 and y equals 4x minus 7, and we're going to use a graph to figure out what this solution would be. I'm going to start by graphing y equals 2x minus 1 in blue. I know my y-intercept here is at -1. My slope is 2. Oh, sorry about that. And then we'll graph y equals 4x minus 7 in green. And we can see where they cross is right here. That is the point that they have in common. And that point, that ordered pair, looks like we're at 3, 5. So 3, 5 is the solution because that's the ordered pair that makes both equations true. Suppose that one puppy weighs 5 pounds at birth and grows at a rate of 1/4 pound per month over the first several months, and another puppy weighs 4 pounds at birth and grows at a rate of 1/2 pound per month. After how many months will the puppies weigh the same amount? So on our graph, we're going to put months on the bottom. We'll put pounds on the vertical. And so for this first puppy, I will use green. And it was every month it was 1/4 pound, and that puppy started at 5 pounds. So right here is the start. That would be the y-axis, or the y-intercept. And after a month, 1/4 pound, 1/4 pound, another quarter, and then a pound, another quarter, another quarter, another quarter, and a full pound here. And so that would be our graph for the first puppy, and that should be a straight line right there. There's a little dip in there, but you guys see here, you get the idea. And then for the second puppy, that puppy weighed 4 pounds and gained 1/2 pound every month. And so we can see here is where they're intersecting, which is at 4 months. Which is our answer. So that's what they have in common. So at 4 months, they're weighing the same amount. A system of equations that has at least one solution is consistent. A consistent system that is independent has exactly one solution. When this happens, you have intersecting lines. When you have a consistent system that is dependent, has infinitely many solutions, and this is when you have two equations and you realize that they're the same line. When you have the same line, you're graphing it twice, that means that they'd be dependent. There's an infinite number of solutions. They have everything in common. When a system of equations that has no solutions, and then this says inconsistent, that means that they have nothing in common. They're not crossing at all, so they are parallel. They're parallel lines. So consistent means that they're either independent, they intersect at one point, or they're dependent, they're the same line. So they have everything in common. Whereas inconsistent, they don't have anything in common, they're parallel. So if I have, let's say I have this graph, I'm going to graph two lines. Here's one. And here's another. And I can see here that they have one solution because they're intersecting. So this is an example where if you have a system and they have one solution, they intersect. When we have infinitely many solutions, an example of this would be if I had y equals 2/3 x plus 1, and I graph that, and my y-intercept is at 1, and my rise is, let's see here, 2, and runs 3, rise 2, run 3, or down 2, left 3, down 2, left 3. So, oh, looks like I'm off here. Sorry about that, you guys. Okay, so I'm going to connect. So if I see that's my line, it's not on all the points there, but you can see those points that make y equals 2x plus 1. Now if I had another equation like 2y equals 4/3 x plus 2, and I want to put it in slope-intercept form, so I'm going to divide both sides by 2, and I get y equals, and 4/3 divided by 2/3, I'm sorry, 4/3 divided by 2, which 4/3 divided by 2 is the same as multiplying by a half. So that's going to get me 4. It looks like that we're not doing the same here. 4/3 divided by 2, so I'm multiplying by a half, which ends up being 4/6, which ends up being 2/3. So it's the same slope, it's 2/3, and 2 divided by 2 gives me 1, so it's the same line. So you can see here, once I solve for y, I get the same that I had here in blue. So when I'm graphing it, I have the same points. Every single point they have in common, they overlap here. This is infinitely many solutions because they have all solutions in common. If you have a line like y equals 4/5 x plus 1, which crosses at 1 and rises 4 and runs 5, and you have a line that is at y equals 4/5 x minus 2, so crosses at -2 with a rise of 4, run of 5. You can see here they have the same slope, so they are parallel because they have different y-intercepts. They will never cross. They don't have anything in common. When you have a system and there's nothing in common, that's a no solution. Remember, we're looking for what they have in common. So we're going to find a solution of this system, and we're going to graph it. So with this first one, I'm going to divide both sides by 3 to get it in the slope-intercept form. So y equals 1/3 x minus 2/3. And then I'm going to look at my other line here, and that would be, well, if I graph it, so that's going to be at -2/3, so right in that area. Rise 1, run 3. Rise 1, run 3. Or down 1, left 3. So here's our line. Oh, once again. There we go. So here's our line. And now if I take the second one and solve for y, divide both sides by -6, I get -2 divided by -6 gives me a third x, and 4 divided by -6 gives me -2/3. And I see it's the same line, so since it's going to be the same line, it's going to be these same points, all the points they have in common. So this is going to be that they have everything in common. We write infinitely many solutions, because they are the same line, they have everything in common. When we're looking at the solution of this, right away I see what they have in common. They have the 5's here in common. If I have the first one graphed here with blue, it's going to cross at -6. Slope of 5. And if I look at my second one in green, crosses at 4. Slope of 5. Connect that. We see that they are parallel and they will never cross, so this is no solution. They do not have any ordered pairs in common. Can you say I can solve systems by graphing? Write a summary and reflection and be prepared for the work time in class.